Okay, so we're going to talk about the electron transport chain, but first we have to remember the Krebs cycle. The Krebs cycle has our 3-2-1-1 products, but the key product it makes is NADH, and it makes 10 of those. Now NADH is going to come to the first of 3 pumps, and it's going to release an electron. That electron is going to move down the 3 pumps and ends up at that enzyme there. And each of those pumps, 1, 2, and 3, are going to pump out 2 hydrogen ions. Don't worry about keeping track of the hydrogen ions. We're going to make a lot of them, and you'll see where they come from. So we have 10 NADHs. So the reality is that we have 60 H's made. Now 60 H's is an awful lot of H's, and they're going to want to flow back into the system, and they're going to go through that system and follow in through this protein called ATP synthase. So ATP synthase is going to use the pressure of the hydrogen ions to make ATP, and therefore it's going to dump the 60 hydrogen ions back in the middle of the mitochondria matrix. We know from prior knowledge that having an awful lot of hydrogen ions is bad for proteins, so the cell has to get rid of them, or the mitochondria has to get rid of them. But some of those hydrogens are going to be reused in the pump system, and some of them we're going to get rid of. And this is how we're going to get rid of. We finally get to use oxygen for aerobic respiration, nearly the final activity. And the equation that we're going to use to get rid of those the hydrogen is 4 electrons, 4 hydrogens, 1 oxygen makes 2 waters, which leave. So now let's talk about FADH. FADH follows nearly the identical pattern of NADH, except that FADH2 only uses the last 2 pumps. It's also going to release an electron. That electron is going to fire up the 2 pumps and go down the enzyme and ends up there. And it's going to pump out 2 sets of hydrogens. And with the 2 NADHs, we'll have a total of 8 hydrogen ions released. Those hydrogen ions are going to move dynamically up through ATP synthase, making more ATP, technically 4 ATP, and those hydrogen ions will go just like before. Some are going to go back through the 2 pumps, and some of them are going to go into our system where oxygen is going to remove the hydrogen ions so that it is not damaging our proteins and we maintain proper pH. Believe it or not, that was the 40 or so steps of the aerobic respiration. Thanks for listening.